Hello friends, this video Limits and Derivatives Part 6 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1 to Part 5. Now let's discuss algebra of limits. Let f and g be two functions such that limits of both the function fx and gx exist. Let me repeat, there are two functions fx and gx and limit of both the function exist. Then limit of fx plus gx, you combine these two functions and you say limit of this function where x tends to a is equal to limit of fx where x tends to a plus limit of gx where x tends to a. That means addition property holds true for limits. Similarly, in case of subtraction, you subtract these two functions fx and gx and you say limit of fx minus gx and you say x tends to a, that is equal to limit of fx where x tends to a minus limits of gx where x tends to a. Please note, in both the cases for fx and gx, limit exists, that is limit of x tends to a for fx and limit for x tends to a at the same point for gx. Both this value exists. If both this value exists, then only this formula is true. That is, there are two functions and limit of fx at x tends to a and limits of gx x tends to a both exist. Then if you add these two and you take a bigger limit that is similar to you take individual functions, you add individual function or you subtract individual function. Similarly, in case of multiplication also, you say limit of fx into gx where x tends to a, that is similar to limit of fx where x tends to a into limits of gx where x tends to a. In case of division also, same thing holds true. Fx by gx limit is equal to limits of fx where x tends to a divided by limits of gx where x tends to a. But here gx should not be 0, because if this is 0, this will become infinite. We'll take one example here. Let's suppose fx is equal to, let's suppose x and gx is equal to 2x. There are two functions fx and gx. Fx is equal to x and gx is equal to x, and let's suppose a is equal to 1. So first let's prove that at a is equal to 1 fx and gx exist. So first find left hand limit of fx, limit of x tends to 1 minus of fx. This is nothing but f of, let's suppose, 0.999, and that is 0.999. That is almost equal to 1. And limit of x1 plus of fx will be equal to f of 1.0001, that will be equal to 1.001, and that is almost equal to 1. So if you see both are same, so we can say limit of fx at x equal to 1 exists. Similarly for gx, limit of x is equal to 1 minus for gx is equal to g of minus 0.9999, and that is equal to 1.998 or something. That is almost equal to 2, and limit of same gx at x is equal to 1 plus, that is equal to g of x is equal to g of 1.0001, that is equal to 2.0002 and almost equal to 2. So here also if you see, left hand limit and right hand limit are same. So we can say that this also is true, that is limit of gx at x equal to 1 is true. Now going by the first equation, limit of fx plus gx, so limit of x tends to 1, f of x plus gx, that is you can say x plus, and this is 2x, right? F of x plus gx will be 3x actually. So this will be limit of x tends to 1 of 3x. That guy will be equal to 3, correct? And if you add these values fx and gx limit, we have got 1 plus 2, that is equal to. So we have proved that LHS is equal to RHS, because this value f of x plus gx, that will become 3x, x plus 2x. So limit of x tends to 1 of 3x will be 3 into 1, that is 3. And right hand side also we have seen this 1 plus 2, that is 3. Similarly for subtraction, if you see, when you are saying limit of x tends to 1 of f of x, that is x minus gx is 2x, that is limit of x tends to 1 of minus x, that will be minus 1. And here also if you subtract fx and gx, you get 1 minus 2 is equal to minus 1, correct? So both are same. Similarly, we will do for multiplication. For multiplication, you see limit of fx into gx, that is fx is x into gx is 2x, correct? So this becomes 2x square. Now we have to find this function. Let's suppose y is equal to 2x square. Now we have to find this limit of this function, or let's suppose fx gx, we'll call it hx. So we'll call this hx function. So we'll say limit of hx where x tends to 1 is nothing but 2 into 1 square. That is, here also if you multiply these two values which we have got, 2 into 1, and that value come out to be 2, because this is, we have told, is equal to limit of fx, this value we have got 1, into limit of gx, this value we have got 2 into 1, and this value we have got as 2. So here also we can see 2 is equal to 2. Similarly for division, when I say limit of x by 2x, that means this is equal to limit of 1 by 2. So here the hx function is a function whose value is always 1 by 2. So for this function, if I want to find the limit of this function where x tends to 1 of hx, this is always 1 by 2. And right hand side also you see this value is 1 and this value is 2. So if you divide 1 by 2, what you get? 1 by, so here 1 by 2 is equal to 1 by 2. Thus we have proved that algebra of limits hold true for addition, subtraction, multiplication and division. Once again what we have done, we have assumed, let's suppose fx is equal to x and gx is equal to 2x, and we found that limit of this two function at x equal to 1 exists, and those values are 1 and 2. And then we have proved that fx plus gx came out to be 3x. So for function whose value is 3x, limit of x at x equal to 1 is 3, and this is equal to, you add this function fx limit at x equal to a and this gx at x equal to a, that is 1 plus 2, that is 3. Similarly, in case of subtraction, we found left hand side to be minus 1, that is limit of this function where hx is equal to minus x, x minus 2x, that came out to be minus 1, and the right hand side also we got 1 minus 2 is minus 1. In case of multiplication also, in case of division also, we got LHS is equal to RHS. So we have proved that algebra of limits for subtraction, addition, multiplication and division holds true for limits. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.